wanted to show some work. One option here is to think about this like I'm finding area. So I've got an A and a +3, and that's being multiplied by a 2A and a -1. And then in each of the boxes, I'm essentially finding the area of the box by doing length times width. So for this box down here, I've got a +3 by a 2A. So 3 times 2A gives me 6A. For this box, I've got a 3 times a -1. For this top corner box, I've got an A times a 2A, which gives me 2A squared if I'm combining those exponents. And then this final box is an A times a -1 or -A. When I go to combine like terms, I'm thinking I'm going to start with the largest power of A. So that's that A squared piece. And I've only got one squared term, the 2A squared. If I'm going down in descending order with the exponents, I'm going to combine my 6A and my -A to get a +5A. And then in terms of my numbers, I'm just left with a -3. Another popular option that honestly I probably use more often just kind of for practical purposes, and I've been using it for a while since we've been talking about PEMDAS. This is what I call the rainbow method. Sorry, I'll make my phone be quiet. I think I'll make my phone be quiet. So I'm going to keep track of each thing in my first term and distribute it everywhere to the second term. So if I'm thinking about that A, I'm distributing it in to 2A. So when I do that multiplication, A times 2A, I've got 2A squared. And then I'm going to distribute my A to the -1 and end up with -A. And then just so that it's a little bit cleaner on my paper, I tend to distribute the next piece below just to keep track. So 3 times 2A, 3 times 2 is 6, so I've got 6A, and then 3 times -1, that's a -3. I still want to finish by combining my like terms. So that's 2A squared, my -A, and the +6A will result in a +5A, and then -3. We often hear the acronym FOIL, which stands for first, outer, inner, last, which is essentially the order in which I just drew my little rainbows. The reason that I don't like to use the phrase FOIL, we kind of use it as like a verb, FOIL it out, and that's totally fine. We really just need to multiply things. Specifically, the first, outer, inner, last only works if each polynomial has just 2 terms. I've got a 4 and a -x. So I'm going to do what I think are the 3 easy boxes first. X times 4 is 4x. X times -x is -x squared. And 1/2 times -x, I can't really do anything with that, so it's just -1/2. This box, I think, is also not too bad because 1/2 times 4 gives me what? Yes, I know, audience participation, difficult when we're sleepy on a Monday morning. Now, if I go to combine like terms, I'm going to start with my largest power on x, which is an x squared. So I would have -x squared. I'm going to do this in 2 steps. I'm gonna put the 4x and the negative 1/2 x adjacent to each other and plus 2. But in order to combine these terms, I need a common denominator. I'm going to take that plus and just give myself a little bit more room here. In terms of a common denominator, I'm looking at a denominator of 2. So I need that 4x to be multiplied by 2 over 2. Which means I've got negative x squared. 2 times 4x would be an 8x over 2 minus, we talked about this a little bit in the first chapter, but really keeping track of what's in the numerator and what's in the denominator goes a long way in calculus in terms of trying to minimize those mistakes. So right now that x doesn't have anything in the denominator, which means it is in the numerator. So when I put that together, that's negative x over 2. And if I really actually combine these like terms, now that they have a common denominator, 8x minus x would give me 7x over 2 plus 2. Or as an alternate way to write this that is equivalent, we might see that as negative x squared plus 7/2 x plus 2. Both of those are fine in terms of the final answer. This is more likely to be the way something appears in a solution guide or the back of the textbook. Said I would do it the other way too, and I think I can squeeze it in. So x plus 1/2 4 minus x. If I distribute in my x times 4 is 4x. X times negative x is negative x squared. 1/2 times 4 is 2. And then I've got 1/2 times negative x, which is negative 1/2 x. If I arrange these from my largest power of x down to my number, and have negative x squared plus 4x minus 1/2 x plus 2. And I'd have to do exactly the same work to combine these. Since we just did it, I'm going to skip that part and say negative x squared plus 7/2 x plus 2. So if I'm looking at this, each box, I'm getting by multiplying the pieces that are on the sides. So I'm going to have 3x times x squared. I'm going to have 3. And now when I have x times x squared, thinking back to what happens with those exponents, I'm multiplying two things with the same base. So I'm going to add the exponents. This invisible exponent is 1, and I'm going to end up with an x to the third. 3x times 4x. 3 times 4 will give me 12. X times x I can write as x squared. 7 times 3 is 21. And then I've got an x. If I come through and multiply everything by negative 2, that's a negative 2x squared, a negative 8x, and a negative 14. When I go to combine those terms together, starting with my highest power of x, I'd have 3x cubed. Now on my x squared terms, 12x squared and a negative 2x squared, that's a combined positive 10x squared. 21x and a negative 8x, that's going to be a combined positive 13x, and then minus 14. We can also totally do this by keeping track of distributing stuff in. So if I start with that 3x, 3x times x squared, I'd have 3x cubed. 3x times 4x, that's 12x squared. 3x times 7, that's plus 21x. And what I like to do if I'm using this method is I'll actually line up vertically the terms that match. So when I go back through and I multiply negative 2x times x squared, instead of keeping that over here, I'll line it up vertically with the same power of x. So I've got a negative 2x squared, and I'll just put it right underneath that x squared. And then I'll have a negative 8x and negative 14. That way, when I go to combine my terms, everything's lined up for me.